Hey there, tech enthusiasts. It's your boy Linus back again to break down some seriously cool networking stuff. We're talking about the backbone of the internet, the magic that lets your devices talk to each other. Networking is everywhere. It's how you're reading this right now, how you stream your favorite shows, how you game online with your buddies. It's a vast and complex world. But don't worry, we'll navigate it together. We'll be diving into some advanced concepts like IP multicast, CGMP, and even the nitty-gritty of checksum calculations. Get ready to level up your networking knowledge. So, buckle up, grab your favorite beverage, and let's unravel the mysteries of networking together. All right, let's start with IP multicast. Imagine you're streaming a live gaming tournament. Thousands, maybe millions of people want to watch. Sending individual streams to each person would be crazy inefficient, right? That's where multicast comes in. It's like a radio broadcast for your data. One sender, multiple receivers, all tuned into the same stream. This is different from unicast, where it's a one-to-one conversation, and broadcast, where everyone on the network gets the message. Multicast is all about efficiency, sending data only to those who want it. Pretty neat, huh? But hold on, it gets even more interesting. Now let's talk about IP multicast multipath. Imagine your network is a highway and data packets are cars. Multipath is like having multiple lanes on that highway for your multicast traffic. This is where the IP multicast multipath command comes in. It lets your routers use multiple paths to send multicast data. But here's the catch, it's about load splitting, not load balancing. Think of it like this, you've got two lanes and you're splitting the cars evenly between them. But one lane might be smoother and faster than the other. That's load splitting. Load balancing, on the other hand, would be like having a traffic cop directing cars to the fastest lane. Multipath doesn't do that, it just splits the traffic, potentially sending some packets on a less efficient route. So multipath is great for redundancy, ensuring your multicast traffic gets through even if one path goes down. But it's not about optimizing for the absolute fastest delivery for every single packet. Next up, we've got CGMP, or Cisco Group Management Protocol. Remember how we talked about multicast being like a radio broadcast? Well, CGMP is like the system that figures out who's listening to which station. In technical terms, CGMP is a layer 2 protocol that helps routers discover which hosts on their network are interested in receiving multicast traffic for specific groups. It reduces unnecessary multicast traffic on the network, making everything smoother and more efficient. Think of it as a way to avoid sending cat videos to your friend who's only interested in dog videos. CGMP helps routers create efficient multicast delivery trees, ensuring that data only goes where it's needed. But how does CGMP actually work? Well, it involves two key components, GDA and USA. Section 5, CGMP components, GDA and USA. Let's break down these acronyms, shall we? GDA stands for Group Destination Address and USA stands for Unicast Source Address. Don't worry, it's not as complicated as it sounds. Remember those multicast groups we talked about? The GDA is like the group's ID, like a channel number for a radio station. The USA, on the other hand, is the address of the sender, the DJ in our radio analogy. CGMP uses these two pieces of information to build its multicast forwarding tables. When a host wants to join a multicast group, it sends a join message to the router, including the GDA of the group it wants to join. The router then uses this information to add the host to the forwarding table for that particular GDA. This way, when multicast traffic for that group arrives, the router knows exactly which hosts to send it to. So, GDA and USA are like the address labels that CGMP uses to deliver multicast traffic efficiently. Pretty cool, right? Section 6, the power of multicast communication. We've talked a lot about the technical details of multicast, but let's take a step back and appreciate why it's so awesome. Multicast communication is incredibly efficient, especially when you're dealing with large-scale data distribution. Think about software updates, video conferencing, online gaming, and even financial data feeds. These applications often involve sending the same data to a large number of recipients. Multicast ensures that the network isn't bogged down with duplicate data streams, making everything faster and smoother. for everyone. It's like the difference between sending a mass email and having everyone subscribe to a newsletter. With Multicast, you're not just sending data, you're optimizing how it's delivered, and that's a beautiful thing. Section 7, Bluetooth versus Wi-Fi, a head-to-head comparison. Now let's switch gears a bit and talk about two wireless technologies you use every day, Bluetooth and Wi-Fi. Both let you connect devices wirelessly, but they have some key differences. Bluetooth is like your best buddy for short-range connections. It's perfect for connecting your phone to your headphones, your keyboard to your computer, or even your smartwatch to your fitness tracker. It's all about low power consumption and ease of use. Wi-Fi, on the other hand, is like the high-speed internet connection of the wireless world. It's designed for higher bandwidth applications like streaming, gaming, and browsing the web. Here's a quick breakdown. Connectivity: Bluetooth is point-to-point, connecting two devices directly. Wi-Fi connects devices to a network, usually through a router. Power consumption: Bluetooth is a power sipper, perfect for battery-powered devices. Wi-Fi is more power-hungry, especially at higher speeds. Security: both have security protocols, but Wi-Fi generally offers more robust encryption options. Flexibility: Bluetooth is super easy to pair and use. Wi-Fi requires a bit more setup, but it offers much wider compatibility. Range: Bluetooth is short range, usually up to 30 feet. Wi-Fi can cover a much larger area, especially with range extenders. Bandwidth: Wi-Fi blows Bluetooth out of the water when it comes to speed and data transfer rates. So, which one is better? It depends on what you need. Bluetooth for personal connections, Wi-Fi for high-speed networking. Both are essential tools in our wireless world. Section 8, Demystifying Reverse Proxy Servers. All right, let's talk about reverse proxies. Imagine you're hosting a website. You don't want all the traffic coming directly to your server, right? That's where a reverse proxy comes in. Think of it like a bodyguard for your server. It sits in front of your server and handles all the incoming requests. This helps protect your server from direct attacks and can even improve performance by caching content. When you visit a website using a reverse proxy, your request goes to the proxy first. The proxy then forwards the request to the actual server, retrieves the content, and sends it back to you. Reverse proxies are super useful they act as a buffer, protecting your server from direct attacks. They can cache content, speeding up delivery for users. They can distribute traffic across multiple servers, preventing overload. So, if you're serious about web hosting, a reverse proxy is your friend. Section 9. Addressing in datagram networks. Let's dive into the world of datagram networks. Imagine you're sending a postcard. You need to write the address on it so it gets delivered to the right place, right? In datagram networks, data is sent in small packets, and each packet needs an address to find its destination. This address is called the IP address, and it's like the postal code for your data. Each device on a network has a unique IP address, just like every house has a unique address. When you send a packet, you include the destination IP address in the packet header. Routing tables maintained by routers act like postal workers, using the destination IP address to determine the best path for your packet to reach its destination. It's like a giant interconnected postal system for your data. Section 10, one's complement arithmetic and checksum calculations. Hold on to your hats because we're about to get a bit mathy. Let's talk about checksums. Remember how we talked about data packets traveling across networks? Sometimes those packets can get corrupted along the way. A checksum is like a safety check for your data. It's a small value calculated from the data in the packet. The receiver then performs the same calculation. If the checksums match, it means the data arrived intact. One's complement arithmetic is a method used to calculate checksums. It involves some binary addition and flipping bits, but the main idea is to create a small value that represents the integrity of your data. Think of it like this. You're sending a fragile package. You carefully pack it and add some bubble wrap. The bubble wrap is like the checksum, protecting your data from getting damaged in transit. Section 11, piggybacking in networking. Last but not least, let's talk about piggybacking. No, we're not talking about hopping on someone's back for a ride. In networking, piggybacking is a way to optimize data transmission. Imagine you're having a walkie-talkie conversation with your friend. You say something, then you have to wait for them to finish before you can talk again, right? Piggybacking is like saying, "Hey, While you're at it, can you pass me that water bottle? It's about combining multiple pieces of information into a single transmission. In networking, this means sending acknowledgements, confirmations that data was received, along with regular data packets. This reduces the need for separate acknowledgement packets, making communication more efficient. However, piggybacking also has some drawbacks. If the piggybacked acknowledgement gets lost, the sender might resend data that was already received. So there you have it. We've covered a lot of ground, from the basics of IP multicast to the intricacies of checksum calculations. I hope you enjoyed this deep dive into the world of networking. Until next time, stay curious and keep those networks humming.